Okay, let's get going. So welcome everybody. My name is Jordan Last. I am LastMJS on Twitter or the forums. Um, Today I want to give you all an overview of something I think is very exciting that is coming. Everything we're going to see today is real and it's working on my computer, but the project is highly experimental. So you'll probably have to wait, towards the end of the year for a full 1.0 release, but you can get started and start experimenting if you are adventurous. But basically what we're going to go over is writing canisters in TypeScript or JavaScript. So right now there are two main languages, as you know, to write your canisters in. One would be Rust, an extremely amazing, robust, efficient, like hardcore software engineering language that I personally love, but it is not beginner friendly at all, really. It's quite a difficult language to learn, even if you've been doing this for a while. So the foundation decided to create a domain-specific language called Motoko, which is the namesake of this bootcamp. And Motoko is much easier to learn. It's much more similar to very popular higher level languages like JavaScript. But what if you could write your canister in JavaScript or TypeScript, kind of using them interchangeably? I think personally that is going to be a huge boon to development. It's going to break down barriers to entry. If you're a web developer coming over to the internet computer, the idea is that you could bring all of your skill and all of your knowledge, all the little idioms and nuances of TypeScript and JavaScript that you need to learn, just bring those over to the internet computer, and you could actually write entire applications front end to back end in TypeScript. And that's kind of what Node.js or Deno have brought to the web development world as well. The fact that you can now, well, for the last like 10 or 15 years, maybe 12 or 13 years, you can write entire applications in TypeScript. And it's just very nice to be able to reuse all that knowledge. So that is my goal with Azel. And Azel is now being stewarded by my company called Demergent Labs. We are going to be a small team, but we're going to be full-time working on things like Azel, Pseudograph, and Kybra to bring Python, TypeScript, and GraphQL to the internet computer community. So let's wait a little bit more on the benefits. You may have noticed Motoko is a very new language, right? So sometimes it's hard to find materials. You're not going to have 10 years worth of blog posts or 10 years worth of YouTube videos or all kinds of extreme experts. It's just a little more difficult. With TypeScript, we get all of that. We get hopefully NPM, one of the biggest open source repositories in the world. And hopefully we can kind of reuse a ton of code and just be super productive. So let's get going. If you are interested, the repository is right here on GitHub, Demergent Labs, Azel. Like I said, this is extremely experimental. It does work. Like I have been able to deploy actual canisters to the internet computer and they run, but I cannot promise security. I cannot promise efficiency. And currently the build is actually broken. So I'm doing this all from my computer. So the point is, this is very experimental. But like I said, if you are interested in using this, you can get in contact with me. Twitter, Telegram, Open Chat. My handle's the same, LastMJS, and I'm happy to work through getting you set up if you are that adventurous. So with all that, let's make an example project. So super simple. Motoko Bootcamp TypeScript. I just made a directory and I put all the normal stuff in it. For a web project, you generally have a package.json. Really easy. Azel 0.0.8. Like I said, this build is actually broken, so I am doing it from my local computer for now. But once it's working again, it's very simple, just package.json. And then your dfx.json is going to be extremely similar to what you have done, except we're using the custom type. You put in a custom build command, and all you do is you say Azel and then put in the name of your canister. So I'm calling my canister backend, you need to say the root directory of your canister. So notice here I have a directory called source. This is where the source code of my canister is going to be. So you need to specify that. Then you say, what is the entry point into your application? So the entry point to an Azel application is going to be a TypeScript file. And so I specified it. And then where's your candid? Where do you want your candid to be? Azel will automatically generate your candid for you, so you don't need to write it by hand. And then you do need to specify where the WASM is. Basically, it's always going to be this path, and then you just put in the name of your canister right here. So a little more complicated than a Motoko or even now a Rust dfx.json, but not too bad. You just copy paste this every time and change it basically. And now let's get into writing some code. Beautiful. We have a blank slate. It's just a TypeScript file. Let's write our hello world. So we're going to import the query type from Azel. And then we're just going to export a function called hello. It's of type query. It'll return a string. And we'll say world. Okay. Super simple. This is a hello world in TypeScript. Technically, you don't even need this export. Actually, maybe you do now. I don't know. But look, that's it. Let's deploy. It's going to take longer to compile than Motoko code. Pretty similar to the Rust build times, I think. But over time, hopefully we can make the build faster. But it's basically taking your TypeScript code, compiling it into basically compiling into Rust, you can think of it that way, and also generating your candid types for you, and then taking that wasn't binary and deploying it. So we're deployed. Notice that your did file was generated for you. So there you go. And now we can call it. So dfx canister call backend hello. There it is, world. There you go. We just wrote canister in TypeScript. And we should be able to, if I did dfx deploy network IC, which I will not do right now, I mean, it should just deploy to the production internet computer and actually work. So, all right, that's awesome. Let's look at some more features. Let's do an update call. So let's do a simple counter. Let's use the I32 type. Start off at 0. Let's make a function called read. That's a query that will return an I32. So I created a variable called counter of type I32. I initialized it to 0. This will automatically be persisted with orthogonal persistence for you. And then we're just going to read it here. Again, this is how you tell Azel, well, tell the internet computer, I guess, that it's a query function and its type is I32. So there we go. And then let's make an increment function. This is an update call, and let's just return a Boolean. Actually, let's return an I32. We'll return the current count. So we'll just add 1 to the counter and then return the current value of the counter. Okay, so orthogonal persistence, super simple. And now we've added update calls. So let's deploy that. While that's deploying, there's all kinds of types in here. We've got our U64s, U32s, U16s, U8s. Your I64s, I32s already up there, I16s, I8s. There's a NAT. There's a VEC, which I'm not sure works super well yet. But the point is, all your primitive data types are going to be available to you. So nothing complicated there. Okay, let's call read. Okay, it's an int32. The current counter is at 0. So let's increment. This is an update call. It should take a little bit longer. Okay, it returned 1, but let's call read just to make sure that it actually persisted, and it did. Let's call increment again. 2. Let's call it a couple more times. 3. 4. And let's read. 4. Okay. So orthogonal persistence is working. That's all you got to do. This is just straight up TypeScript. So far, I mean, nothing. I mean, this is canonical, awesome TypeScript. So it's pretty nice. Let's look at some of the Internet Computer APIs that are available to us. So if there's an Internet Computer object that you can import here, and this gives you access to all of the Internet Computer APIs. So for example, if you want to know what time it is, that is a U64, I believe. So let's import our U64 type, and then we return IC.time. So notice this will return a number, which under the hood is going to, I believe is a U64. And this is going to use the Internet Computer System API to get the current time. We'll deploy that. And then let's just do a few others while we're waiting. Well, let's see what we have inside of here. I mean, here's the type. Yeah, caller, cache balance, ID, print, time, trap. So let's get the current canister ID. I believe that'll be a string. This is the ID of the canister. Let's get the caller. So we want to know the principal of the caller. You just say ic.caller. You can also print. So we'll just make this a query that returns a boolean. We'll return true. And what's cool is I can print. Actually, yeah, we'll take a message in here, and we'll print the message. So that will actually print in the replica process will actually print. So your local replica. And then we'll do one more. Trap is nice sometimes. Make that a boolean. So IC.trap, this will actually trap, so cause an error and stop execution, but you can provide a message with the trap, which is nice. And that should never return because it will trap right here. Okay, we will deploy these in a second. So yeah, the time. There we go. It is a U64 or a NAT64. And if I call it subsequently, notice that the time is changing. So time works. Let's deploy again all of the rest of these APIs here. Some limitations. Obviously, I'm kind of showing you the happy path, things that work really well. Right now, you cannot do any kind of asynchronous operations. For example, cross canister calls. Because that is an asynchronous operation, there are some very technical reasons why that's not currently working. You cannot do any cross canister calls. Getting randomness from the random beacon, I believe that's asynchronous. You cannot do that right now. Anything that calls into the management canister, you cannot do right now. Only synchronous APIs are possible. So in that way, it is quite limited. But in other ways, you can actually build quite a lot within a single canister. So, all right, let's do some of these. What do we have? Oh, and notice our candidate is being generated for us, which is very nice. In Motoko, I don't even think you have this file, but in Rust, you do. And I think Dfinity is moving towards pushing people to check this file into their repository because it's the interface to your app. So it will generate that for you, and you can check it in. Okay, let's check our canister ID. Yep, RRKAH, whatever. Let's check the caller. That should be my principal, which probably isn't smart to show you, but there it is. Let's print something. This is printing, so it returned true immediately. But if we go over to the replica process, notice that it printed from the replica process. So that's how you can kind of debug things. And then let's trap. And again, a trap is basically an error that will stop execution. And what's nice is that you can provide a message. So notice it returned an error immediately, and here's our message, it trapped. So there you go. Yeah, let's, I mean, look, I'll do just a couple more examples. So we can make like a simple database. So let's make a type called DB. And this type has keys that are strings and values that are strings, just a really simple database. So we can initialize it like this. We create a variable called DB of type DB, and it's just an empty object. I mean, this is just basic TypeScript stuff. So if you're not familiar with TypeScript, this might be confusing, but if you are familiar with TypeScript, you should notice that this is extremely simple. So we'll do a get, and you just pass in a key, and you should get back. What have I done? Oh, export function. It's pretty simple. We'll just return DB key. Now, if that happens to be undefined, it will break. So let's use nullish coalescing and say not found if the key's not there. Let's make a set function, pass in a key and a value, which are both strings. This is an update call, and let's just return Boolean saying that actually worked. And here we'll say DB key equals value. That should be all you need. Okay, this is a very simple database. We've got a getter and a setter, and it's just a very simple key value store. So let's deploy that. If I had a MacBook M1, this would probably be very fast, but I don't. And what's nice is notice we're using our normal DFX commands to do everything. So, okay, our database, let's check our did file. Awesome, we have a new get function and a new set function. And let's go. Canister backend. Let's get a key that doesn't exist. You know, foo should not exist. It should return not found. Perfect. Let's set something. I don't know, like using a key of 0, and then the value will be a 0 written out. This is an update call. So if I get key 0, it should return 0. Perfect. Set 1. Okay, so we have a very simple key value database working. Get 0 and then get 1. Nice. Nothing crazy there. Let's do a slightly more advanced database. So let's say you might want to have like a user type, IDs, and usernames. I like to make my databases something. I just like to make a state type. And so in our state, we'll have users. And this will be a key value store of users. So basically, my state will have one property called users, which will be an object whose keys are IDs and whose values are users. So I'll make a state variable of type state here and initialize it as an empty object with one property called users. And what's nice, okay, what's nice is we inherit all of the TypeScript tooling. So if I do it wrong, no, you know, it's type checking for me, which is great. I mean, that's the amazing thing about TypeScript is it's going to cut out tons and tons of bugs before you even try to deploy your code, because you do not want to deploy something and have it break in production, right? It's much better for the computer to tell you beforehand, which is why I don't recommend writing in straight up JavaScript. I recommend TypeScript, though. Azel will let you write in JavaScript if you want to, except the functions that you expose, any query function or update function, and the types. Those have to be written in TypeScript. Otherwise, you wouldn't be able to. The internet computer would not understand what's going on because it needs explicit types. It needs static typing. And so basically we take the TypeScript and convert it into candid. And you have to do that. With Python, it's the same thing. Python historically hasn't had a type system, so it wouldn't really work with the internet computer. But Python has, well, as far as I understand, it has recently implemented type annotations of some sort. And so you will need to write the type annotations for your query update functions and any parameters to those functions and the return types. But other than that, you can just write straight up Python if you want to. Though I highly recommend using static typing in whatever you're doing. So, okay, so here's our user type. Here's our state variable, or our state type, and here's our state variable. Now let's write a couple easy functions to get some users. So this will be a query function that returns users. So I'll make a type called users up here. It'll be an array of users. Also, this is a limitation currently that should go away, but we need to use this candid type here because we are creating a more complex type than a primitive type. So we just need to tell the compiler basically that these should be turned into candid. I should be able to remove the need for this later on. So, but what users will do is we'll just go grab all of the values in state.users. Object.values will grab only the values. So notice we have key value pairs, the keys and ID, the values of user. Object.values will just grab all the users and return them as an array. And notice the types all work out here. So if I said object.keys, it would break because the types don't match. Object.values does not break, so we're good. Should be good at least. And then let's make a function called create user, and we just pass in the username. This will be an update function, and we'll have it return the user. So first, we want to grab the next ID, and we'll grab it like this. We'll say object.keys state.users.length, and we'll turn that into a string. Okay, that should be our next ID. And then let's create our user, uptype user. Okay, notice there's type error because I need to fill in the fields. ID will be next ID, and username will be username from up here. Then we're going to say state ID equals user. So we'll update, state next ID equals user. So we'll actually update our state. And finally, we'll return this user. Okay, so pretty simple. Hopefully that makes sense. We'll deploy it. And notice I'm just using my TypeScript knowledge. Like, there's very little to do with the internet computer here. Like, you had to learn to wrap your return type in a query and an update. That's very, 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 very simple in my opinion. And you just have to use some special types. But I mean, you do that in any statically typed language, basically. So, and then this candid type is going to disappear. So in my opinion, this is a very, very simple developer experience. Okay, deployed. So let's do get users. We should get an empty vec. Perfect. And let's create a user. I'll create myself. Last name.js. It should return. Perfect. It's a record. ID is 0. Username is last name.js. If I get users, oh, that's surprising. Oh man, what happened? Update user. Oh, Okay, that's unfortunate. So it didn't tell me that I didn't do that. That's the problem. DFX. So that's a TypeScript nuance, I suppose. So it allowed me to set a property called property whose key was 0 instead of forcing me to use this user's thing. So that was my fault. It would have been nice for TypeScript to tell me. There might be a way to force that, but I don't know it right now. But nothing was wrong with, okay. And now let's create this user again. Okay, now it should have worked. Perfect. Now we have a vector of records. Let's make another. My friend Bob. Okay, see username 1 or user ID 1, and then get users. Now we have 2. Okay, well, that's, I mean, that is the gist. So you basically import what you need from Hazel. This gives you access to the Internet Computer's APIs. Other than that, just use TypeScript. Make types, make variables of certain types, make functions, and put the right types on them. And that is how you program canisters in TypeScript. So hopefully Hazel will be beyond extremely experimental soon, and hopefully it'll only be experimental soon, but right now I'm working through some issues. So that is my project. So happy to take questions if there are any.
So yeah, anyone just go ahead and raise your hand if you have a question. And okay, there we go. Andrea.
Hey Jordan. Hey everybody. So are you with Hazel? Is your intent to kind of take over Node, like just bring Node over to the IC, so that
Yeah, basically.
It's pretty cool. It's pretty cool.
Thank you.
Pretty dope. All right, any other questions? And Jordan, did you give a rough estimate on the availability you expect, like for when it's more stable? Or
I mean, I would expect a 1.0 release by the end of this year, which means like super amazing, stable benchmarks tests. To be able to use it, I mean, that should come pretty soon, like days or weeks. I mean, you like I said, if you contact me, you could use it right now. To get so all synchronous APIs should be usable pretty soon. To get cross canister calls and any kind of asynchronous API, unfortunately, that is going to require some engineering effort in the JavaScript engine I'm using. So that actually might take a few months, but I would expect by the summer, hopefully it'll be like full featured, but still beta, I suppose.
Well, I can't wait to see it being used heavily in an upcoming bootcamp.
Yeah, that'd be awesome.
All right. Oh, yeah, that's someone's writing about, imagine the body of WebView devs when they say you can write contracts for Bitcoin in TypeScript. That's true. It'd be pretty earth-shattering once we have integration with all these other blockchains. Yeah. Any other questions from the group? All right, well, I think we're good there. Well, we'll go ahead and end this one early then. Everyone, thank you so much for watching. And Jordan, thank you so much for working on this. This is going to be a really amazing contribution to the ecosystem. I think we're all really excited to see it come through.
I appreciate it. Thank you.
All right. Bye.